Hello everyone, welcome to my YouTube channel Programming with DP Wala. Hope you all are doing good. Today we are discussing the problems from the Leetcode weekly contest 386, and today's contest was relatively on the harder side. The third and fourth problem was very interesting, and very few people able to solve the third problem, and the acceptance rate of the fourth problem was very less. So let's discuss the first problem, and I will be explaining the third problem in a very efficient manner, trying to explain it in a very efficient manner. So let's start with the very first problem. So here the first problem from this contest is split the array. So here in this problem we are given an integer array nums of even length, and we need to split that array into two parts, nums1 and nums2, and there are three conditions given, that is the length of the first array and the second array should be same, that is an n by 2 length, and the nums1 should contain a distinct element and nums2 contain the distinct elements, means or both the arrays should contain a distinct element, and if it is possible to generate or divide it into two parts, so it will return true and false. This is a very simple problem. So here the intuition behind it is that, let's say, if let's say see this test case, 1 1 2 2 3 4. So here we are having a count of 1 as 2, 2 as 2, and 3 and 4 are single one. So here what we can do, we will put one in one array and one in another array, so that duplicates will be not present in the same array. So here the intuition is very simple, that let's see if the count of any of the element is greater than 2, means there is no way to put the third element in array, that it will not lead to duplicacy, because let's say 3 1 are there, so we will put 1 1 in one array and 1 in another, when one that is left, where we need to put in any of the two arrays, right? So there is no possibility to make it a distinct one. So here what I have done, I have created a map, calculate the frequency of every number, that if any of the number is having frequency greater than 2, means we can't able to split the array into two equal parts, and duplicacy will be there, so will return false, otherwise will return true. This is a very simple problem, and you need to do it very fast to get a good rank, because what happens mainly, we need to save our time in these easy problems. So let's move towards, so now rather than explaining the second problem, I will be explaining the third problem first, because many people face to solve the third problem and the acceptance rate is very less. So I will try to explain the third problem. So let's see. So here we are given a third problem here. The name of the problem is earliest second to mark indices one. So here let's see the problem. So here what we have given, we are given a two one index integer array, nums and change indices, which are having length n and m respectively. So initially, all indices in nums are unmarked. Your task is to mark all indices in nums. So we are given two arrays, nums and change indices of length n and m. Initially, all the elements in nums are unmarked. We need to mark all the elements in num. So there were three operations that we have given, that they have given three cases. In each second, in order from 1 to m inclusive, we can perform one of the following operations. So from 1 to m seconds, means 1 to m we are having a total 1 to m time. So we need in each operation we can perform any of these three operations. So one is, we can choose any element in nums array and decrement the value of that any of the element by 1. Second operation that we can do is, we can select nums change indices of s is equal to 0, mark the index change indices s. Means what we need to do, as we are decrement the value of nums in nums array, let's suppose if any element becomes 0, at that time only we mark that element, right? And the third operation is do nothing. So here what we need to return, we need to return an integer denoting the earliest time in the range 1 to m, when all indices in nums can be marked by choosing operation optimally, or -1 if it is not possible. So here what we need to do, we are given a nums array and change indices array. We can do three operations. We can decrement any value of the nums array, And second operation that we can do is that if any of the element that becomes 0 in nums array, we can mark that index as marked. As earlier, all the nums elements are marked as unmarked. So here I will take one example and try to explain with it. It is a extended version of this example only. So I will try to explain it with the help of that. So let's see. So here, let's say we are having elements, or we can say two arrays that we are given. So here what we need to do, we need to perform, we can say, as in the question they have given that we can perform the three operations. So let's take this example. Let's say we are having a nums array as 3 1 2 1. So here one base indexing is there. So you can see here that one base indexing is there. So I am doing it in 1 to n. So rather than 0 base indexing, they have given a 1 base index. So always remember that you need to see this as well, because many people face difficulty in this as well, that whether there is a 1 base indexing or 0 base. So see this as well. So these are the indexes and these are the array elements, nums array. Now I will be taking the change indices element 1. I will taking this array. I am taking this example. The reason behind this is that so that you can get that the proper idea behind this problem, that how to approach this. If you are thinking that how I come with this example, so you can see the second test case, that sample test case that is given in the question. By seeing that, you can definitely create your own array to dry run it, so that you can get the proper idea about the question and how to approach this problem, because really the today's contest is really very interesting. So this is the change indices array. So here I will mark that 1 2, this is the time, 4 6, these are the timing I am writing, 8 9 10 11 and 12. So these are the time t. So let's say, so here what we need to do, in the question that we have given us, first operation is that we can decrement any of the nums. So let's understand. Uh, this one. If any of the element is 0, we can mark it. So we can't do this element until the element becomes 0. So we need to do the first operation in the first part. The reason behind is that second operation we can't do without the first one. So here let's we are thinking that which element to choose to decrement it. Yes, this is the good question that one can think of before attempting this problem, that which element to decrease. So here let's say till what index we can decrement, we need to make that element 0. So here these are the timings and these are the indices. So we can see that for the first index, you can see for the first index you can apply operation on first index till time 4 only, because after time 4 there is no one, means there is no operations that can be done after 4 seconds. So here we need to make we need to mark all the array elements, and we can mark only when array element becomes 0. So we need, so till time 4 we can say we need to make the index one element to be 0 to make it as marked. Hope you understand this. So this is the biggest hint to solve this problem. So here what one can do is that one can create a last index of every index. Let's say till what time we can do operation on that particular element. So let's say for index 1, till what time we can do operation on it? Till time 4. Right? So these are the timings we are storing, and these are the index. Hope you are getting this problem. I am explaining it very slowly so that you can understand it very properly. These are the timings till when we do operations on that index. So let's say for index 2, till what time we can do operation on it? We can do operation on it till time 12. Till time 12 for 2. Similarly, for time 3, for index 3, till what time we can do operations? We can do till uh, you can do till time 9. You can see here, right? So till time 9 you can do this for index 3. Similarly for index 4, till what time you can do operations? Till time 11. So what I have done, I have uh, stored all the last time till which I can apply operation on this nums array, right? So you have narrowed this. So what you have done, you have break this problem into some solvable hints. So what you have done, you till this time you can for particular element or at that index you can do operations. So now the biggest question is that for now we get the last point. So to select which element based on it. So here this is very simple. So the one which is having a less time means for one we can see that here till 4 seconds only you can do operations on it. After that you will not able to do operations. So till 4 you need to decrement 1 only. So this is the biggest thing that we need to sort this. So here we can sort it based on the indexing, based on the time. So 4. So first we need to do for the index 1 element. Then we need to do it for the index 3 element. That is 9. Then we need to do it for the index 4 element. That is 11. Then here we need to do it for the index 2 element. That is 12. Time I am talking about. So here this sequence we are following. So here what we do when we are at time 1. So which element to select? We will be selecting this element 1 only, element at index 1 only. The reason behind it is that because its time is less and till 4 only we need to make it a 0 to be marked A. So here the element becomes 2 as we have taken. So we have applied the first operation as they have given here. Then we are here. Here we will be taking the same element. We will be decrement it by 1. We will be checking that whether the time is less than this one. Yes, it is less, so we can do. We will be moving here. So whether time is 4, no, time is 3. So we will be decrementing here. So now it becomes 0. Now it becomes 0. So now we will be here. So we will be checking that whether at time 4 we will be able to the element becomes 0 or not. If element is greater than 1 means after that we won't be able to mark that element, we won't be able to make it 0. So we simply return false here, means we simply return 0, means we won't be here the answer is -1. The reason behind it is that we won't be able to mark the index 1 element as 0 as we need to mark all the elements. So here we need to break. So this optimization condition here we can apply. So as the element is 0, so here we will be marking it and we will be going with the second element, that is index 3 element. Similarly, we will do it until end when all the elements are marked. We will be returning the time when all the elements become marked. Let's say till we can say till 9. The elements, all the elements are marked. So we will be returning the this time. Hope you got the approach. So what we are doing, we will storing the last time till which we can apply operation at a particular index, and we'll be storing it in this index, this array, and we'll be sorting it because we need to apply based on the time only, and we'll be applying this operation. So here we are doing it greedily, and this problem is quite easy. So let's see the code so that you can understand it in a proper manner. Hope you got the approach. This question is quite difficult, but if you generate a proper array and you dry run it and you think in terms of greedy, you can definitely go able to solve this problem. This problem is not that much difficult, but proper understanding is required. So let's see the code. So here, what I have done, this is n is the size of the nums array and m is the size of the chain indices array. So here we'll be running for time 0 to m, right? So we'll be checking that check earliest second, means can we able to make the element, all the element marked till this time. So we'll be passing time, nums array, change indices array, and we'll be parsing it. If we able to, if it returns to means till this time plus one because it is a one based time, as they have mentioned, it is a one based indexing. So time plus one will be written. If it is not possible, then we will return minus one. As I have mentioned, the condition of false. The reason is that if you won't be able to mark all the element, then you need to return minus one. So let's see this check earliest second function. See here what I have done. I have created a vector last indices. Here you can see that this is the last indices vector that I have created. Means we are storing the last time till which means till that point we can apply operation that particular index. So we are storing that. Let's say suppose for any of the element, means if any of the for any of the index in one based indexing, if the last index is minus 1, means we won't be able to mark, so we have written false. So after that what we have done, we required two things. Here you can see the one is the time, another one is the index. So for this we'll be required a pair. So we'll be storing a pair, last position, we can say last time till with till that point we can apply operation on particular index and the index. Okay, we are storing it only last index and that particular index. We are sorting it as I have mentioned in the explanation part. So here what we need to do, we have created a used variable. I will be explaining it. We are running a for loop for the vector pair. So here what we need to do, the required value is nums of itr.second. Our second value is nothing but the index. So that particular index, so as we are storing it in a one based indexing, so we have done index minus 1. So we will be adding means we required one operation for it, so we are adding one. Here I have done the reverse engineering. What you can do, you can decrement it as well. What I am doing, I am adding an operation. So here, so used value plus required value, if it is greater than the means the last index plus 1, what I need to say here is that here what I am doing, rather than decreasing the current element by 1 here what I am doing, I am adding it till the last position, means till this time plus 1 I am adding it. Once if let's say use plus required is greater than itr first plus 1, means let's say here what we have done, if if at this point this element it still not become 0, means when we reached at the last index of that till which we can apply operation on 4 operation on index 1, if it not becomes 0 till that point as well, means we won't be able to mark that index. We will be simply returning false. Otherwise, we will be adding a required in our used. Means we need to check further as well. Let's say if it becomes 0 and we successfully marked it, we simply return true and we simply return time plus 1. So this question is very easy if you got the approach. So I will and I will briefly tell you once again that what we need to do. We need we are given a nums array, we are given a change index array. In nums array, all the indices elements are given, and in change indices we are given an indices. So we can apply three operations. One is choose index I and decrement the nums I element. And if that nums I element becomes 0, at that time we marked it because earlier all the elements in nums are unmarked. So the first thing what we have done, we have think in terms of that which element to choose for decrementing. So on the basis of its timing, means till what time we can apply operation on that. The one which is having a less time, we will be choosing that element first because this is the most appropriate one. This is the most optimized one at that particular one. So whenever you need to choose the optimized thing at that particular time, then we need to think in terms of greedy. This is the biggest hint for this problem. And after that, till this point, if we able to make it 0, means it is a good. If we won't, we simply return false at that time. When we simply return -1, we won't be able to mark. So this is the biggest hint for this problem. So these are the explanation for this problem. I have skipped the second problem here. The reason behind is that I thought that second problem is solved by many people, but the third one is the good question and it requires a good understanding. So I thought to take the extra time for it so that everyone can understand it. And this problem is really, really very interesting, and this is a very beautiful greedy problem. If you got the approach, please try it by your own, dry run it once again and write code by your own so that you can get the approach behind it. So hope you got the approach behind it. Hope you understand the problem in a very better manner. Thank you for listening this tutorial, and I hope you understand the problem in a very efficient manner. If you watch this video till this point, please don't forget to like, share and subscribe to my YouTube channel and stay connected for more such Leetcode, code shape and code forces contest analysis. Thank you. Happy coding.